All right, guys. What is it? Let's get started today. So, do you guys see the chalkboard? I mean, not the chalkboard, the whiteboard. You guys see it pretty good.
It's a little blurry, but if you use like a black marker, you should be able to get a good move.
All right, hold on. How about now? Is it a little better?
Yeah, a little better.
Yeah.
All right. And you guys hear me good too, right? Better than before. Into just the stuff that I wanted to talk about today. Airport operations and specifically on the traffic pattern. And then I wanted to talk about two types of landings, two landing techniques that people do in general aviation. But before I hit those points, just real quick, I wanted to go over what what an airfoil was and just the basic principles of flight. Basically, what an airfoil is any part of the airplane that gives off lift. So any part of the airplane that gives off lift is called an airfoil. And basically here, the most forward point edge and the most rearward part of the airfoil is called the trailing edge. And if you draw an imaginary line from the trailing edge to the leading edge, just like that, this right here is called the chord line. Like when you play piano or you play an instrument, the chord line. And then there's four forces of flight, right? So you got lift up here. You got thrust or power. And then you got drag. And then, okay, I don't remember the fourth one. Can anybody fill me in? The four forces of flight?
Wait,
It's
Gravity. Is it gravity? Let me just Google it real quick. Four forces
I thought it was weight.
of flight. Yeah, weight. Wait, there it is. Weight. It's been a while since I taught this lesson. So thrust and power is a forward motion. Drag is a negative motion, and there's three types of drag. I believe it's parasite drag, induced drag, and one more drag. It's in the what is it called?
profile drag. Profile drag.
Parasite. What drag?
Profile.
Oh no, not that one. Prophilic drag, right? Is it called prophilic? Three types of drag is skin friction drag. Sorry, so there's parasite drag, and three types of drag. Anyways, in that video, and then just real quick, and then we have the lift right here and the weight right here, and then the wind that comes directly forward and into you is called relative wind. Relative wind meets the chord line. This is called your angle of attack, your AOA. So this is pretty important to know when you talk about stalls. And so just real quick, basically what happens is, here's our airfoil again. So according to this principle called Bernoulli's principle, basically the pressure when it hits the leading edge, the wind breaks off to the top and then breaks off to the bottom exactly at the same time at the leading edge. So because top of the airfoil, the distance between A and B on the top side is a little bit longer. So in order for the wind, the airflow that's traveling on top to meet the time, what needs to happen on the top side? It needs to move a lot faster. So basically on top, you have the low pressure because it's moving faster. And then on the bottom, you have the high pressure. So just to signify that, I'm gonna just draw positive and negative signs. Here's the positive, 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 positive. You got the negative, 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 negative air pressure. So what's happening is the high pressure is giving the airplane the lift, like this. There's like 3 or 4 types of lift theories. This is all theories, by the way, because nobody can prove how airplanes fly like exactly to the science, right? This is all theories. So basically, what a stall is when the angle of attack meets a critical point, and so you got the airflow flowing on the top and you got the airflow flowing on the bottom. But when the angle increases due to the relative wind, at one point, the airflow that's moving on the top is not going to be able to meet the bottom airflow at the end. So basically what happens is the airflow on the top is trying to meet the airflow on the bottom, but as it's going and the angle of attack increases, it starts breaking off, just like that. So it's not able to reach the airflow that's continually coming on the bottom. So when it breaks off, you no longer have the high pressure meeting the low pressure up top, so there's no more lift, and that's why the airplane stalls. All right. I don't know if I did a good explanation, but I'm just trying to guide you guys into the ballpark area. So when you guys see that YouTube or when you go through the PHAC, you can understand what I'm talking about. Okay. So I'm just trying to break it down to the human level. All right. So today, what I wanted to talk to you is about the traffic pattern. And what a traffic pattern is you know how like in Australia where you have the roundabouts. Everybody knows, like nobody has to tell anybody what to do when you reach a roundabout, right? Who has the right of way? The people who are inside the circle, right? And just like that, like everybody knows what to do. Same thing with aviation. When you head out to an airport and you're coming to land at an airport, regardless if there's a tower or there's no tower, you got to know what a traffic pattern is and what the airport operations is, right? So basically, the parts of a traffic pattern, I'm going to explain to you. A standard, does anybody here know what direction the standard traffic pattern goes to?
Left.
Anybody know? Yeah. Oh, damn, Taj, killing it. Yeah, so Taj knows. Yeah, it goes to the left. So basically, in IFR, the standard, when you're doing it for general aviation and VFR, the standard traffic pattern is to the left, okay? So right here, I'm gonna just draw an imaginary runway. Let's call it runway. So basically, this part of the leg right here, where you take off and you go forward, is called the upwind. All right? Somebody have a question?
Sorry, I
Somebody
forgot
just
to turn
turn
off.
their mic
My
on.
apologies.
You okay, Taj? All right. So right here, this part of the leg is called the crosswind. All right? This part of the leg is called the downwind. And according to what side the runway is on, so here's my airplane, right? Here's my airplane, and it's going on. So I took off, I went on the upwind, and then I went on the crosswind, and I turned to the downwind. Depending on what side the runway is, like right now, the runway would be to my left side. You would call it the left downwind, or you'll call it the right downwind. All right. So basically here, because the runway is to the left of you and of the airplane, it's going to be a left downwind. All right.
So when you're parallel
right
to
here,
the runway. So sorry, when
Yeah,
you're parallel to
yeah.
the runway in a traffic pattern, that means you're in the downwind.
Yes, when you're parallel to the runway, it means that you're on the downwind. And I'm sorry, I forgot one point. This point on the middle of the runway, abeam the runway, we call it midfield. Okay, this is called the midfield. This is all important parts that you need to have memorized inside your head. Okay. And as I said, if the runway is to the left of you, you call it the left downwind. If the runway is to the right of you, you'll call it the right downwind. Okay. And then right here, this leg, I got a terrible handwriting. I'm sorry. This is called the base leg. This portion of the traffic pattern, right? And then right here, this point, we call it abeam the numbers. Abeam the numbers. And then the final point of the runway, we call it final. All right. So a standard, I'm sorry, is all the writing opposite by any chance? Is it coming like the
Yeah,
writings are?
no, it's fine. We can see it just fine.
Oh, it's not backwards? Because when I look at it, it looks like I'm drawing it backwards.
No, it's not backwards. I just need to confirm. When you're right of the runway, it's a right downwind, and left is a left downwind.
Exactly. Yeah. So if I was here, if I was on this side, and my airplane, right, was flying this way, this would be the right downwind.
I have a question there.
Yeah, sure.
What does abeam the numbers mean?
It means when your airplane is the numbers are exactly abeam you. That's called abeam the numbers.
Okay.
Does that make sense?
When do you use those phrases?
All right, I'm gonna just draw this a little
Like
bit.
when
more
you
clear.
say,
All right. Make the runway a little bit smaller. So here's the upwind. Upwind. Here is the crosswind. Here's the left downwind. Here's the midfield. Here's the a beam point. Base and final. All right. The reason why you need to know this is because whenever you go to an airport, which you will a lot when you do your private pilot training, if you ever train at an uncontrolled airport, you need to let people know in the surrounding area where you are inside of that traffic pattern so they know exactly where you are, right? So, for example, just like if I was in a Piper or if I was in a Cessna and I was taking off runway 0, this would be my call out. Okay, let's say my Cessna was a white and blue Cessna, right? So I would say, hey, white and blue Cessna taking the roll runway 20. So everybody knows that I'm on the runway and I'm taking off. And I'm letting them know that I'm going to be staying in a left traffic pattern, right? So as soon as I take off, I'm going to let people know, hey, blue and white Cessna is on the upwind. Like, let's call this Farmingdale traffic, because that's where I am right now, right? So you let the people know, hey, Farmingdale traffic, blue and white Cessna on the upwind runway 20. So now anybody in the surrounding area and anybody on that frequency is going to know, oh, this guy is exactly on the upwind. He's going to know exactly what point I'm in, right? As soon as I make that turn, I'm going to say, hey, Farmingdale traffic, blue and white Cessna is on the left crosswind from runway 20. So now everybody's going to know that I'm going to be somewhere in between this point and this point. right? I'm gonna say, hey, Farmingdale traffic, blue and white Cessna is on the left downwind for runway 20, right? And then when we get to the midfield, we wanna let people know exactly where we are. So the reason why we do that because the downwind is kind of long, right? The crosswind from your upwind to your downwind, the crosswind area is kind of short. It's a small area. So if you say crosswind, people are gonna have a general vicinity of where you are. But the downwind, they might not be able to see you because it's such a longer point. So when we're here on the midfield, we'll let them know, hey, Farmingdale traffic, blue and white Cessna is on the left midfield downwind for runway 20, right? Then on the base, same thing. Hey, Farmingdale traffic, blue and white Cessna is on base for runway 20. And then on final, we're going to say, hey, Farmingdale traffic, blue and white Cessna is on short final for runway 20. So short final means anywhere from 3 miles in, right? And further than that, you could just say final. It doesn't matter. You're just letting people know that you're coming in to land. So you don't want short on this taxi line in his airplane to just roll onto the runway as you're coming into land. If that's the case, then you're going to have to go around, right? So this is the parts of the traffic pattern. One other part you need to know is the entry of the traffic pattern. So the way we enter a traffic pattern when you're coming back to an airport, regardless if it's it has a control tower or if it's uncontrolled, we always want to enter in the 45-degree entry from the middle of the runway into the traffic pattern. So here's the 45-degree angle right here. Here's my plane. My plane has big wings, right? So I'm going to be entering the traffic pattern on the 45-degree angle, all right? So this part is called the entry. Usually, I'm not going to teach exactly, like every CFI is going to have a different point to do your checklist and whatever. But what I tell my students is when you're on the entry, that's when you want to do all your landing checklists. So like if it was a Piper, when we're on the entry, we're doing landing light on, fuel pump on, mixtures full rich. And then, if we have a landing gear, we're going to say, we're going to put the gear down on the entry. So on the entry, you have to be fully configured, except for the flaps. And a traffic pattern altitude, we call it the TPA. Usually for general aviation and aircrafts, it's 1,000 feet AGL, 1,000 feet above the ground level of whatever airport you are at. So like the airport that I'm at today is Farmingdale, New York, Long Island, and their traffic pattern, their ground elevation is about 75 feet. So their traffic pattern altitude is 1,100 feet. So basically when you're on the entry, whatever altitude you were at, you got to come down to whatever traffic pattern altitude it is. So for today's sake, let's just say traffic pattern altitude today is 1,000 feet. Okay. So once again, here's the entry. Here's the midfield point. This is a beam of numbers. You got the base, the final, the upwind, and the crosswind. So this is the different parts of the airport.
I have a question there.
Yes.
How far is the distance between the runway and your downwind? What's your distance?
Oh, the parallel point you're talking about?
Exactly. How far from the runway is it in the airport?
I think the book in the PHAC, the airplane flying handbook, not the PHAC, but the flying handbook, it says it should be anywhere between 1/4 a mile to 1/2 a mile. So in between that, if that makes sense.
And that you kind of eyeball it, like if it's a certain airport, will you know, or do you have to eyeball it a little bit sometimes, or?
I mean, you're gonna eyeball it every time.
Okay.
And I usually tell people to be at a distance where if you lost an engine, if you lost everything, you can still make a turn onto the airport. So that's my distance. Like just in case I lose power or I lose the engine, I'll be able to glide it down into the airport and land it safely. All right. So I'm gonna
Oh.
just yes.
When do you say a beam? Do you ever say a beam the numbers, or you just a
Yeah, I mean,
reference?
yeah, because if somebody says, "Hey, Farmingdale traffic, any state your location," right? If somebody asks you to state your location because they want to know exactly where you are and they don't have you in sight, you can say, "Hey, I'm on the left downwind, beam the numbers runway 20."
Okay.
Does that make sense?
Yeah.
So then they're gonna know exactly where to look at, and they'll be like, "Oh, okay, that's where he is."
Okay. And so let's say you're taking off from the opposite side of the runway. I don't know what the heading is, but would you do? Would you take a
Mhm.
right turn or would you do a left turn? Because it wouldn't need be a left
It
pattern.
Yeah, I mean, it depends. Every airport has their traffic pattern. If you look into the sectional chart, or like if you have ForeFlight or whatever, it's gonna tell you if it's left traffic or right traffic for that airport. And so even the same way, that's the way you're gonna depart, right? So let's say like, here's my runway. I'm gonna just call it runway, changed up the runway. And let's say you're on the runway and you're going to go to the southeast or you're going to go to the south, right? So the way you're going to depart the runway, if you're going that way, you're going to just head out straight on the upwind. You don't have to turn crosswind or you don't have to turn left downwind and exit that way, right? But if you're going to go to the north, the way you're going to depart the traffic pattern is you're going to go on the upwind and then you're going to go on the crosswind, and then you're going to go to the midfield point of the left downwind, and then you're going to break off to wherever you need to go.
Right. Okay. Thank you.
All right.
Peter, what is it called? The point between the numbers and the final approach when you make that left?
Point. Can you say that again? I'm sorry, I didn't understand the question.
The point from the numbers to the final approach. What is that called again?
I think
Oh, okay.
a
So
beam the numbers.
here's our runway.
I think that's what I.
No, I think he means
are you
means
talking
base.
about a beam right
When you
here?
turn you mean right before final, Oscar?
When you make the left turn from the numbers to the final approach. What is that point called?
Yeah, that's
Base.
Oh, it's called right here. It's called final.
Okay,
Okay.
base. Okay, cool. Thank you.
Yeah. So basically, what I wanted to talk to you guys today, like we talked about taking off the airplane, and we talked about climbing and descending and whatever. Now we have to talk about how we're going to get back to the airport and how we're going to land the plane, right? So in order to do that, you guys need to know what the traffic pattern is first, right? So the way we're going to do it, I'm going to explain it for a Piper Warrior or a Piper Archer or whatever, and a Cessna 172 or Cessna 150. It's the same thing, right? Damn, Officer Torres, you're an officer. All right, so here's the runway one more time. Here's runway 20. And so I'm going to explain how everything works now when we're coming in. So when we're coming into the airport, once again, as I said before, we're entering in a 45-degree entry point, right? Here's the entry. And this is where we're going to do our landing checklist and our landing configuration. We have to be fully configured for landing here, right? And usually for a Cessna and a Piper Archer, we're going to slow the airplane back to about 90 knots, starting from the entry, okay? So usually those planes, they cruise at 100 knots or 105 or 110 or whatever. But when we start coming into the airport environment, we're slowing down the aircraft to 90 knots. And also what we're doing is we're descending down to the traffic pattern altitude. All right. So now we're in the midfield right here. We're on the midfield point, and we're on the left downwind for runway 20, right? So if there's a tower, like if there's a tower at the airport, they're gonna say, okay, report when you're midfield, because the tower doesn't know where you are. He doesn't know where you're in the entry. He's just waiting for you to be in a visual sight so he can control the landing traffic into the airport, right? So now we're here and we're at the midfield point, and there's no traffic ahead of us. There's no airplanes ahead of us. It's just you and you're coming in. So we're at the left midfield downwind. So this is where you start configuring the airplane to land. And so on the downwind, we're at 90 knots. And at abeam the numbers, right? This is the abeam point. And the beam point means where your wing is parallel to the point of landing, the intended point of landing, right? So we want to land on the numbers or whatever we want. This is the point where we want to touch down on the airplane. This is where we're going to chop our power, right? So the airplane should be about 2100 RPM or 2200 RPM, whatever it is to maintain 90 knots. So let's say 2200 RPM right here. When you get to abeam the number at that point, you're going to bring the power back of the airplane to about anywhere between 1500 RPM to 1700 RPM. So just it should be around that. So I'm going to just say 1700 RPM. All right. So at the abeam point, there's a couple things that we're going to do. Bring the power back to 1700 RPM. And then the next thing we're going to do, whether it's a Cessna or whether it's a Piper, we're going to put in our first notch of flaps. First notch flaps. All right. So just before I go further into the landing phase, for a Cessna, the first notch of flaps, I think Cessna flaps goes 10 degrees, 20 degrees, and 30 degrees, or 35 degrees. I'm not too sure. But the first notch of flaps for a Cessna, it creates lift. The second and third notch of flaps for a Cessna, it creates drag. Okay? It slows the airplane down, right? So when you put that first notch of flaps in, you're going to feel the airplane want to balloon up. All right? For a Piper, the first two notches of flaps is for lift. So 10 degrees, the airplane's going to want to balloon up. And then the second notch of flaps, the airplane's going to want to balloon up again, which is 20 degrees. And then the last notch of flaps, which is like 40 degrees, it's going to want to come down. It's drag. So those are the two differences of the airplane, but that's about it. And it doesn't matter. The way you're going to land is going to be the same way, right? So abeam the numbers, 1700 RPM, and first notch of flap. The most important part that people forget to do is you have to initiate a descent, all right? Descend. So you remember last class I talked about when you descend, you have about 6 fingers from the dash to the horizon, and that gives you about a 500 feet per minute descent. Same thing. You want to lower the nose of the aircraft, and you want to start descending down, right? So when you descend down, you should be descending down at the traffic pattern anywhere between 300 feet per minute to 500 feet per minute. So you got to start coming down. And you're going to keep on going down on the downwind, and now you're probably asking, when do you turn is when you are from where you're sitting and the runway, when you're at a 45 degree angle from the intended point of landing. All right. And once again, do you guys see this? Just to make sure. Is it dark enough? It's dark enough. Okay. So when you're at that 45 degree point of your intended landing, remember, we're still descending down. So at this point, if the traffic pattern was 1,000 feet, right? At this point, you should be around 700 feet. All right. This is all like just ballpark numbers, right? So around 700 feet, you're turning the base. Here's the base leg. And for the base leg, what you're going to do is you're going to turn that base leg as soon as your airplane gets wings level. you're gonna add your second notch of flaps, whether it's a Cessna or your Piper, whatever. We're adding your second notch of flaps.
Hey Peter, I have a question. Can you so let's say you're doing touch and go landings and you factor in the altitude that you turn crosswind at. Can I just factor in that altitude where I turn base and use the same altitude for when I turn crosswind to when I turn base?
Negative. The reason being is because of the wind. Because if we're landing runway 20 right now, when you're turning that left crosswind, you have a headwind. When you're turning base, you have a tailwind, right? So it's gonna be different, right? So that doesn't matter that much. But what happens is when you turn base, you got your second notch of flaps in. I'm gonna just put 2 flaps. And what's gonna happen is when you put the flaps in, the airplane is gonna slow down a little bit more. And because like for a Cessna, the second notch of flaps is drag, you want to drop your airspeed from 90 knots to about 80 knots. On your base, all right? So on the base, what's happening is we're dropping our second notch of flaps in, and then we're slowing the airplane down to 80 knots.
I have a question there.
All right?
Oh, sorry.
Yeah, of
when
course.
you're on the traffic pattern and it's there's an air traffic controller, do they have to tell you when to take your turns, or can you just announce like I'm on downwind, I'm on final, or do they tell you?
No, so if there's a control tower, what's going to happen is he's just going to say when you're on the downwind, he's going to say, "Hey, Cessna 3 November 3456, clear to land runway 20." That's all he's going to say. So then that means you don't even have to announce you're on left downwind or left base or whatever. He knows where you are. He just cleared you, and the runway is yours. Okay. So and they know that you're going to go out. You're going to extend the downwind to a point where you're 45 degrees from where the point you want to land. So it's not like you're going to turn base all the way over here. Right? You're going to turn base when you're 45 degrees. So you're within his airspace.
Yeah.
make sense,
When
Taj?
is base to like when you go to final? Are you usually always on a short final, like 3 miles, or are you a little bit longer? Like when is that turn? How far are you?
Yeah, that turn should be around anywhere between like 3 miles and 5 miles, I think. Right? Because basically right here, if you're here 700 feet, by the time you get to final, you should be about 400 feet when you get here. Right? And then from 400 feet all the way down, if you look at an ILS chart or whatever, or like an instrument procedure chart, a 3 mile out of final, it should be around 500 feet. So you're in the ballpark, right?
So wait,
So
when you said be at 400 feet, that's at final, correct?
Yeah. But this is like the altitudes. Don't pay attention to these altitudes. The important stuff is the RPM, the flaps, and your rate of descent, like 400 feet per minute, 300 feet per minute. That's the important stuff, right? And also when you make your turns is important. When you're 45 degrees from the point, that's when you turn. Because let's say you made your turn at 800 feet or 900 feet for your base, it doesn't matter. You can fix everything up when you're on final, right? Like all the correction can happen when you're on final. You just need to be in the ballpark of the descent angle for the runway.
I got another question there.
Yeah, go ahead.
When you're on downwind and you're going to your base and you're kind of base to final and you're taking that turn and you realize there's like a lot of wind and you don't want to use too much like kick your rudder, so you don't want to stall on it. Like as I've heard, like pilots try to kick too much rudder to get that turn better, and then they just end up losing control. Or you have to go like there's a plane in your way on final or something like that. How do you get out of that? Will you have to go around the runway, or like if a plane was landing to kind of cut you off and you're on down or base to final, what do you do?
The procedure for a go around is basically you're gonna fly to the right of the runway, parallel to this runway, and then commit the go around.
Do you just enter in through the the 45 degrees.
No, so if you're on the base and somebody cuts you off or whatever, which will never happen because they cleared you to land, but all you're going to do is you're going to just turn. If you had to go around, you're sidestepping the runway, and then you're going parallel to the right of this runway, and then you're just going out on the upwind, and then you'll probably join the traffic pattern again. Okay? So I'm going to just continue real quick. So we talked about what happens on base. At base, we're at 80 knots, our second notch of flaps. And then on final, what happens as soon as you turn final, we want to bring that airplane to about 70 knots on the airspeed. All right, so we're at 90 here, we're at 80 here, and we're at 70 knots. And you might be asking, when do you want to add that third notch of flaps, right? When you want to add that third notch of flaps is when you're confident, even though your engine shuts down or you lose your airspeed or whatever, you're going to be able to make the runway. So when you have the runway made, that's when we add the third notch of flaps. So usually about 200 feet or 100 feet away from the runway, we're dropping that third notch of flaps into land, right? And you're talking about with your base to final turn that you might stall or whatever. Well, think about it. Our speed that we're keeping right now on the traffic pattern is 80 knots. Our stall speed for a Cessna or a Piper is probably down at like 54 knots or 55 knots, if I'm not mistaken.
I checked for a
All right.
Cessna 172 is 65. So 70 would be
For
pretty.
the stall?
Yeah. It's a landing
Are you
speed.
sure?
Yeah. Something like that.
No, that's a landing speed. That's the
Oh,
touchdown speed. That's not the stall speed.
okay. For the for stall cleanup is 50 knots. And then
50 knots.
43
clean,
for,
right? But think about it.
yeah.
43. Yeah, so we have all our flaps, and so basically we're at 80 knots, and you have 40 knots of window. I don't think you're gonna stall.
Yeah.
Does that make sense? Okay. Does that make sense, guys? No?
Yeah, I have a
So
question.
you can go first.
Yeah, when do you know as 45 degrees when you're turning to the base? Like, with how do you know that?
Oh, guesstimate, man. Pilots we're guessing all the time.
All right then.
Okay. Yeah.
Shooter, so when you're about like, I'd say like 200 to 100 feet, what should your speed be at? Like what, 70, 60?
So so you're at 70 knots, right? So basically what's going to happen is when you have the runway made
Right.
and you add your third notch of flaps, this 70 knots is going to automatically, because the last notch of flaps is drag, right? It's going to slow down to 65 knots, right? And as somebody else just mentioned, that 65 knots is technically the landing speed of the aircraft. So you're at 65 knots on short final, right?
Right.
So that's how it works. So when you touch down and when you
Okay.
start flaring and you start getting close to the runway, you're going to go from 65 knots all the way down to your stall speed. When you hit your stall speed, your wheels will touch on the ground.
Okay. Thank you.
Okay? Yeah, no problem, man. Yeah, this is like now the stuff that we're talking about is like it's real. It's like a little bit more detailed and stuff like that. So definitely keep on reading up on the PHAC, and just with my online course and the PHAC and airplane flying handbook, everything should start mixing in and you should start understanding, right? And like I said today, there's two types of landings that I wanted to talk about. So 2 types of landings. The first method of landing I want to talk about wing low method. Right. So the wing low, you guys see the board good, right?
I see it okay, I guess. I just listen
Okay.
mostly.
Okay. So basically, what a wing low method is, your wing is dipping, or the wing is banking into whatever direction the wind is coming from while you're coming into land, right? So basically, if this is the runway, I gotta draw, sorry. It's a big runway here. Let's say runway 32, whatever. And here's your airplane. So, and the wind is coming from this side. Wind. Okay. Wind is blowing this side. So basically what a wing low method is, no matter what is happening to the current environment, a point on the runway, here's a point on the runway, the nose of the aircraft and the tail of the aircraft all need to be aligned, all need to be straight. All right. So basically what's going to happen is, if the wind is blowing on this side, the airplane is going to want to either weather vane into the airplane, or weather vane into the wind, or it's going to get pushed out to the right side. All right. But in order to maintain the center, keep the plane straight, basically what's going to happen is your aileron, I mean, not your aileron, your yoke is going to look something like this. It's going to be facing into the wind. So the control stick or the yoke, the flight control, is going to be facing into the wind. So what happens when you do that, right? What's going to happen is the airplane, here's the airplane, it's going to want to bank to the left, and it's going to want to turn to the left. You see, it's going to bank to the left, it's going to want to turn to the left. But in order to counteract that, what's going to happen is you're going to step, if you have two rudders, you're going to counteract that by stepping on the right rudder. So basically, you're cross-controlling the airplane all the way down. And because you're doing that, I'll show you real quick. Here's a ghetto airplane that I have. So basically, once again, let me line it up with you guys this way. So when you're putting your left control in and the wind is coming from the left side, your left aileron makes the airplane dip this way, right? And so when your wings dip to the left, what the airplane is going to naturally want to do is going to turn to the left. But basically, by putting in the right rudder, it's straightening out the airplane. So you're going to be coming down all the way to the final, aligned with the runway, just like this. And the wing low method is that you're going to have a point all the way, a point on the runway, the point of the nose of the aircraft, and the point of the tail. It all has to be, the longitudinal axis of the airplane needs to be aligned and straight. So let's say if the wind is, you got a strong crosswind, maybe you'll be coming in like this. If you have a light crosswind, maybe you'll be coming like this, right? And basically by the time you touch down on the ground, you'll be touching down with your left main wheel first, and then your right wheel will come down later, and then your nose wheel will come down last. So it'll be like a wheelie landing. So it'll be like boom, boom, boom. Okay? Any questions on that? No? Does it make sense though? Like, does it make sense to you guys?
Yeah, it makes sense to me.
Okay, sounds good. The next method, just me personally, by just been teaching for many years, this method works very good when you first start out in aviation. They struggle with keeping the center line of the runway, but by doing this, you're from all the way back and final, from 3 miles away from the runway, you're aligned the whole time. So basically, you can align the whole time, all the way down from final way back there to short final to the runway. So this way works out very well for beginners who are starting to practice how to land, right? The second way of landing is called basically what the crab method is. This is the way that all airliners and people who have two engines on their aircraft, this is the way they land. Because if they do a wing low method, and let's say like a Boeing 737 or whatever has the engine on the bottom, if you bank it too much when you land, what's going to happen? You're going to scratch the left engine or whatever, right? So to counteract that, the way people in the airlines land is a crab method. Here's the runway again, runway 32, right? Here's the wind. Wind is coming from the left. And here's our airplane. Because the in order to maintain center line, you're going to have to turn the yoke to the left, right? Just like how we did for the wing low method. But now what's going to happen is when you do that, the airplane is going to weather vane into the wind. And now all we're caring about, we're not caring about the nose of the airplane or the tail of the airplane. We're not caring about none of that. All we're caring about is the pilot itself. You the pilot. So from you, the pilot, to the center line of the runway or the point on the runway, all we're doing is we're matching that. We're staying straight in that regards. Doesn't matter how hard the wind is blowing or how strong the wind is blowing. All we want to do is we want to be aligned, our person who's flying the airplane and the runway itself. And you're going to be coming down sideways the whole way onto the road until you get to the runway. All you're doing is you remember you had the two rudders in here. You're going to be stepping down on the right rudder gently, and what that's going to do, we call it kicking the aircraft or kicking the nose of the aircraft or whatever. It's going to rotate because of the rudders. The airplane's going to rotate straight, and eventually, when you're about to touch on the runway, you're going to be perfectly aligned. And this is what you do when you're in ground effect. So when you're about like anywhere between 12 to 6 feet off the ground, this is when we're kicking the airplane over. And basically, when you do that, the airplane's going to land with the two main wheels together, and then the nose wheel is going to come down. But you're going to notice that the controls on the wing low method and the crab method looks the same at the end. It's the same outcome. Okay. So basically, when you guys start flying and you guys start landing the airplane, to some people, the crab method is easier because for a crab method, controlling the airplane on final, because you're already weathering into the wind and all you're doing is just coming down nice and easy sideways. And also, everybody in the airplane is not banked or tilted, right? Everyone's straight, so everyone's comfortable. And a lot of people prefer this method, and a lot of people prefer the wing low method because for wing low method, you're always aligned with the runway, and but the passengers or whoever might be a little bit uncomfortable because you're coming sideways down to the runway the whole way. All right. So this is the two methods of landing, and that's what I wanted to talk about. All right. So I think I'm going to conclude the lesson today here, and at this time, I'll take any questions and about the lesson or whatever you guys have.
I have a quick question there. So, like that crab method, basically, you just gotta keep keep yourself as a pilot straight on, like look at the runway, and then just don't worry about like the angle of the plane. But if you're there,
Doesn't matter. Yeah.
Cool.
It's gonna be your body itself and the runway.
Okay, I get that. Thank you.
Yeah.
So for the low wing method, right, the first one,
Yeah.
do you
Yeah.
always have that nose? So even if you have like I would say 7 knot crosswind, do you always still have it like aligned? I don't know if that's fast or not, but do you always have it aligned, or do you
no matter
crab too?
no matter what the wind is, if you're doing a wing low method, you're always straight. The point on the runway, the nose of the aircraft, and also the tail of the aircraft behind you, we all have to be aligned. The longitudinal axis of the airplane needs to be straight with the runway the whole time.
But you're also
Yeah.
moving the wing, so you're going into the wind, I guess.
Yeah, the yoke's going to be a little bit toward the left, right?
Oh, so the wings are gonna move, but you're not fully gonna be crabbing.
Yeah, because we're going to have the opposite rudder. So if wing is tilted a little bit to the left, the airplane's going to want to turn to the left like this. But because
Yeah.
we have the opposite rudder in,
It's just gonna
we're
keep straight.
cross-controlled a little bit. Yeah, it's going to keep straight.
Oh, okay, I understand now. Thank you.
Yeah. Any other questions? Yeah. Hey, Josh. Yeah. Basically, I think personally, I started off with the wing low method, and I think like during my instrument rating or my commercial rating, I switched over to the crab method. So I feel like for beginners, the wing low method is a little bit easier to do because you feel safe the whole time. Like you're not making an abrupt control change like on the ground where you're kicking the airplane over. You know, you're aligned straight the whole time. After like couple hours, like maybe like 50, 60 hours, everything becomes a little bit slow motion. So I think that's when I eventually started doing the crab method. Yep. So I hope you guys enjoyed today's lesson. That's all I had for today. Yep, and I'll just try to keep on chucking along with this class. All right. So I appreciate you guys watching, and I'll see you guys on Monday. All right.
Thank you.
Thank you.
Thank you.
Hey, see you
Thank
see you
you.
later.